here we are going to discuss about a theorem. In the previous video we have discussed about zeros of an analytic function, and we actually dealt with some examples also. Here we are going to see a theorem that is related to that. Suppose f of z is analytic in a region D and is not identically 0 in D. Then the set of all zeros of f of z is isolated. So we are given with an analytic function in region D that is not identically 0, which means f of z is not equal to 0 for all z. So actually what I am trying to say is f of z is not a constant function if the value is equal to 0. Then the set of all zeros of f of z is isolated. Isolated in the sense, for example, if a is a 0, then I should find a neighborhood of a in which f of z should not have any other 0. அதாவது நான் வந்து a 0ன்னு எடுத்துக்கிட்டேன் அப்படின்னா ஏவை சுற்றிலும் ஒரு நெய்பர்ஹுட் கண்டுபிடிக்கணும். அந்த நெய்பர்ஹுட்டில் எனக்கு f of zக்கு ஏவை தவிர வேறு ஜீரோஸ் வந்து இருக்கக்கூடாது. சரியா? So here I have taken an analytic function. Let f of z be analytic in a region D such that f of z is not identically 0. And then I have taken a 0 to be a. Let a be a 0 of f of z where a belong to D. So என்ன ப்ரூவ் பண்ணணும்? ஆல்ரெடி சொன்ன மாதிரி we have to prove there exists a neighborhood of a in which f of z does not have any 0. That is, I have to find a delta greater than 0 such that in this neighborhood my f of z should not have any zeros. Okay, fine. So this is our claim. So I already have taken 0 to be a. Now I am going to take that order of this a to be r, which means as per the definition f of z can be written as z minus a the whole power r multiplied by a function phi of z, where this phi of z is analytic and a and phi of a is not equal to 0. Have this. And listen, so here phi of z is analytic, right? So it is continuous at a also, which means given epsilon greater than 0, I should be able to find a delta greater than 0 whenever z minus a less than delta, then phi of z minus phi of a is less than epsilon. So here I am choosing my epsilon to be equal to mod phi of a divided by 2. So for this epsilon I can find delta greater than 0 because phi is continuous at a. So which means when mod z minus a less than delta, mod phi of z minus phi of a is less than mod phi of a divided by 2. Have this. So in this neighborhood, consider this neighborhood. So I'm going to concentrate my attention to this neighborhood alone. So here a is here in this neighborhood. Suppose in this neighborhood my f of z has another 0, that is b, that is not equal to 0. Is a 0 of f of z in this neighborhood mod z minus a less than delta. I have taken like this. Let us see what will happen if I take like this. Actually என்ன பண்ணியிருக்கேன்னா இந்த நெய்பர்ஹுட்டில் f of zக்கு ஏவை தவிர ஒரு 0 வந்து இருக்குன்னு நான் எடுத்திருக்கேன். சரியா? ஓகே, ஃபைன். ஸோ அப்படி எடுத்தனால, so this is as per the definition we already discussed. F of z is equal to z minus the whole power r phi of z. That equation I have written. So since b is a 0 of f of z, f of b is equal to 0. That is, b minus a the whole power r phi of b is equal to 0. So we have already taken b is not equal to z, which means b is another 0 other than a, which means b minus a is not equal to 0. That implies this phi of b should be equal to 0. So listen, so this is true for all z such that z minus a less than delta. It's because my b is in this neighborhood. This is true for b also. Therefore, b minus a less than delta implies mod phi of b minus phi of a is less than mod phi of a divided by 2. Since phi of b is equal to 0, mod phi of a is less than mod phi of a by 2. Is this true? Is 1 is less than 1 by 2? No. It's not true, right? Which means this is also not true. Therefore, this is a contradiction. Why am I having this contradiction? Because I have assumed b is not equal to a is another 0 of f of z in this neighborhood, which means this neighborhood does not contain any 0 other than a for f of z, which means in this neighborhood a is the only 0 of f of z. That implies I can able to find a neighborhood of A in which f of z does not have any 0 other than A. That implies the 0 A of f of z is isolated. Since A is an arbitrary 0, I have taken a 0, which means all zeros of f of z is isolated, where this f of z is analytic in region D and this f of z is not identically 0. Okay, I hope you understand the proof of this theorem. We'll meet again in the next video. Thank you.